Okay, so this is going to be an update for problem 15. This problem, for those that don't remember, was the lattice paths problem. Feel free to go back and watch the video to recap on what it was. But yeah, basically we ended up solving it, but just not in a very good way. It used recursion, and the loops ended up like insanely long. This is the code here that you can see on screen. So the problem was we had to put n equals 20 in and get a result. And now if I just run this with n equals 15, you can see like already this is taking absolutely ages. I'm not even sure if this actually runs in time, like for it to be shown on video. Let me just drop this number down a bit. And maybe it does, maybe it's 15 seconds it takes. Let me try 14 a sec. Just want to show how long this actually takes. So 14 takes 3 seconds, 13 takes nearly 1 second, and then 15 I think will take 14 seconds, but we'll see. So basically I found this new, well, it's not new, but it's new to me, new method of like caching results. So in a couple of other problems, like the longest Lattice sequence, so we've got 13 seconds for this. So in the problem with the longest Lattice sequence, I used a dictionary to cache values and therefore be able to stop like having to recurse over things too many times. The dictionary would keep track of things I've already done. And I found a module built into Python that basically does this caching for you and has some quite handy features in it. I don't understand all of it, but I've used it and it's pretty impressive, so feel free to look it up in your own time, but I'm just going to show it now. So it's from functools. You want to import liu underscore cache. Whoops, not like that, I guess. And then what you want to do is you want to decorate your function. Now if you don't know what decorators are, feel free to go look up a tutorial on them. I don't feel qualified to be telling you what they are basically, but I sort of know enough about them to use them. So you want to say at liu cache, and then we have to put in a max size, or it will default to a max size if you want to just use the default, so we'll use the default for this. And what this will do is it wraps this main function inside this liu cache function, which I'm going to show you in a sec with the functools code up here. We'll get to that in a sec. So it basically wraps it in that, and then we'll take the properties from it. So, and what this function here is going to do is therefore then start caching results. So rather than having to recurse over and like, won't go into too much detail of the problems with this, but basically it ends up having to work out certain values for x and y like many different times. So for example, like if we put 15 in, it might end up that like x being 13 and y being 13 is then like checked maybe 5 or 6 times and pinged for like an answer. And using caching, you can only ping it, well, it makes it so you only have to ping it once, so it increases speed. So let's just try running this. See, it's like almost instant, and you still get the right answer. So 401, still the right answer, and it's like what, 0.0005 seconds. So yeah, really fast. And now this means we can actually do what the problem asked, which was to put 20 in there. You see, we don't even get a registered time here. It seems like it's increasing speed, but like it hasn't. It's just my computer must have been running slightly slower when we got this result. And then try a couple of those numbers, so we can put like 100 in here, and you'll see it's still insanely fast. Still barely registering a time. So yeah, just thought it was handy to know. If you ever have like some sort of recursion like this, it might be handy to look into this function and see how to use it. This is the module here that you import it from. So you see this liu cache function as a default max size. Now max size is how big do you want the cache to be. LRU is least recently used, so it basically it, as far as I can tell, it dynamically updates the cache based on important values that it thinks are most likely to come up again. So yeah, max size 128 is the default, but you could put a none in here, and that will mean that there is no max size, or you could put any other number in here. It says it works best with power of 2s, so I'd recommend sticking to like 128 or 256 or whatever. You can read all the specific details. You can read all the specific details of this, like from the documentation. But yeah, this is the code. Feel free to look through this in your own time. Here's the so you see when the LRU cache wrapper. So when you call this function, or when you wrap this function in it, sorry. It's going to pass it in here. This is your user function, so this is the function that you're wrapping. It takes in the max size, takes in the typed, which is this default false. It takes in this cache info, which is this variable up here that it's got. This basically is just for some information, so it means that you can print out. So down here, I remember how to call it. I think it's LRU. No, it's not. It's main dot cache info, I think, something like this. Yeah, here we go. So it tells you how many times the cache was actually hit, and then how many times it was missed. So you can see like how efficient it was. And this can help you with like choosing the correct max size, because no, I won't go into too much detail about that. But basically, some things it might seem like you want to just let max size be none, but that's not always the case. Sometimes it's quite handy to limit the size of it. So yeah, that's it for this one. Definitely check this function out, this LRU cache, because it seems pretty handy for recursive functions in particular. So yeah, thanks for watching, and I'll see you in the next video.